Hi, everyone. Thanks for tuning in to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. As a refresher, I'm a senior product marketing manager with Siemens with a background as an industry-acknowledged subject matter expert of PCB design with over 3 decades of experience. I'm also chairman of the Printed Circuit Engineering Association, PCEA. Joining me today again is Matt Bromley, Vice President of Product Strategy and Technology with Siemens. Matt, thanks again for being here with us. Can you give us a background and some introduction of yourself?
Thanks, Steph. Thanks for inviting me today. Really pleased to be here. I've been at Siemens for 6.5 years. Before that, I was part of the Mentor Graphics acquisition, and I've been in the EDA industry in total for about 30 years now. At Siemens, I'm responsible for a team of subject matter experts, and they're really here to help drive the product roadmaps for all the EBS products. And so what we're really doing is bringing together the market and customer requirements, helping to solve their complex challenges and driving that into the product roadmaps. During my time here, I've had the opportunity to work with many of our top customers over the years and really understand their challenges. And that's really helped me and my team get great insight into many of the most complex challenges our customers have. Particularly more recently around supply chain and the instability they've experienced in the last couple of years.
That's awesome. On our last 2 episodes of the Printed Circuit Podcast, we're talking about the road to resilient enterprise and how we can enable that transformation with the 3 pillars: knowledge, intelligence, and optimization. Today, Matt, I'd like to dig a little deeper into the optimization pillar. Can you give us some insight into what Siemens means by optimization and how that applies to designing for supply chain resilience?
Yeah, absolutely. Maybe before we sort of dive into optimization, let's just set a little bit of context around the supply chain and the industry. If you look back over the sort of history of the industry, maybe for the last 25 years or so, cost was really a driver for most businesses. And so what they were really looking for from a supply chain perspective was how could they reduce cost. And that worked pretty well when the supply chain was relatively stable. You could really see cost as being a function of which supplier you chose or which distributor you chose based on the design that you'd already created. However, what we've really seen over the last couple of years is some dramatic instability in the supply chain. And some of these are due to geopolitical reasons, some of them are due to the pandemic, but it's really got to the point where the supply chain is brittle, it's become very unstable. And it's almost like, Steph, the only insight that we've got into the supply chain is that instability is going to continue. So what have we sort of learned from this? I mean, if we look at this instability and we see how customers are trying to handle this, and one of the things that we see is it's no longer good enough to have development teams that view the supply chain as handing their bill of materials over to component engineering at certain points, seeing some analysis done about whether or not maybe components are obsolete, what their AVL looks like, and then having that information come back. That just doesn't work anymore in this sort of age of supply chain instability and almost the changes in the supply chain happening on a daily basis, right? I mean, we see customers sort of saying, hey, what was in the supply chain yesterday is just not there today. When we think about optimization as a pillar and how that applies to supply chain resilience, what we're really talking about is creating a closed-loop component management system so that we're no longer operating in silos between engineering, between NPI and between maybe purchasing or procurement, but really a much more tightly coupled process within the OEM so that we can really understand the trade-offs between risk in the supply chain and cost in the supply chain at every point from the design right through to the manufacturing.
Yeah, I can definitely attest to that, especially, with all that I've gone through in my career and how we've been functioning in silos or the legacy process to think. So when we look at it today, so are people that are doing purchasing, are they passing their insights over to the engineering teams, or are they looking at the same systems or separate systems, as I said, working in silos and not sharing information? What are you seeing?
Yeah, we see a variety, but we definitely see one of the bigger problems is the siloed approach. I mean, if you look at supply chain information, very often it's contained in an ERP system, maybe an MRP system, and that's shared with engineering, not completely, and also not in a timely way. Very often what we'll see is supply chain information get updated on maybe a quarterly basis, would be sort of fairly traditional. So We absolutely see this siloed effect where information is in different systems. And what's unfortunate in those instances is very often when you have separate systems, Steph, as you've probably seen, right? I mean, what happens is you're passing Excel spreadsheets between systems rather than having them truly connected.
There is a process in place for the most part, but it's a manual process. And in teams that are successful, it's because you have individuals who are stepping up and doing individual tasks, not within a cohesive system with what I would say what Siemens has to offer in our solution, what we're doing.
Well, I was going to say, anytime you have a manual process, you've got error that come into it, right? Manual processes are error prone.
Yes.
That's one of the problems. You've got kind of a data resiliency problem. Are you using the right set of data, whether that be from the design side or the right set of data from the procurement and the supply chain side? And is it timely? I mean, Steph, I've been at customers who've said, we did a design and we thought we could get the components and the next week we couldn't. And the result was we had to do the design again. And so what we're seeing at the customers is very often engineering is spending a large percentage of their time redesigning existing boards just to meet the supply chain problem. So what we really want to do is bring all that data together, right? I mean, connect it digitally, connect that supply chain digital thread, and really shift it as far left as we can.
I couldn't agree with you more. And I can attest to that one step forward and two step backward approach where we design something and, the next meeting we go to, the stand-up meeting or a weekly meeting or project meeting you go to, you find out that what was available is no longer available. And then you start the gauntlet of the loop back and the redundant loops of now I got to go research parts, research circuitry. Is it going to fit? Is it going to meet our requirements? Is it even available today? Who has it? And is the price gone up exponentially where yesterday it was $2, now it's $100, or it's not available not 2 weeks or 6 weeks, it's available next year, potentially. It's amazing how things have changed when we talk about the approach to design and how we're evolving.
I was going to say, there's almost a little amusing anecdote, right? I mean, there's a word that I grew up with in England called gazumping. And what it really was used for was if you were gazumping. Yeah, if you were buying a house and you thought you had a contract in place, for a set amount of money, somebody could gazump you. And what it really meant is they came in with a higher bid and took that. And I've actually heard that used by customers where they thought they had a secure order for a set of components. And they said somebody came in and gazumped us. And, literally came in and took an order away that a component an OEM already thought that they had.
Yeah, in one of my recent articles that I wrote, that exactly happened. And he's a small business and he purchased his parts, did his due diligence, locked in and secured the PO, got the confirmation. Everything is good. It's bad enough the price went up 10x. But then 2 days later, as he's moved on to the next efforts as a business owner, he gets an email saying, I'm sorry, your order has been canceled or has been postponed or pushed back. And his delivery date is TBD. And he got bumped or gazumped, as the term you used. And it is brutal. And he is not the only one that has seen this. As you mentioned, it's getting worse. And, what do we do about it? Another thing I wanted to bring up or at least ask is, I've been hearing and reading a lot about trusted supply chain. Can you talk a little bit about that and what it means in the context of optimization?
Yeah, absolutely right. I mean, you're absolutely right. There's a lot that's been talked about trusted supply chain on multiple fronts. And it's really starting to become a very key topic that we're looking at. And so it's a broad topic. I'm sure we could spend a podcast or two just talking about trust, traceability, and assurance. But, I think one of the elements that we're really looking at from a component side is talking about trust of a single component. And what we've really done here is a lot of work on creating a digital twin of the component. What we have is a standard called the JEP 30. It's part of the JEDEC standard. It was ratified in 2018. That you can really view as sort of being a complete digital model of a component. So now instead of having a model being something like a data sheet and then some files that fly around with that, we've got the ability to create this digital view of a component that then we can sign it to assure its authenticity. Very much like historically, you might have looked at, say, a domain name. And how do you know that Siemens owns a domain name? Well, it's because you have an authority that provides a certificate that signs it. So what we're really looking at, Stefan, one aspect of sort of trust is how can we assure that all the information about a component that a component manufacturer publishes is trusted? And in a very similar way, trusting it through having a certificate that allows you to establish its authenticity.
Just the other day, was sitting in a design class, one of the CPCD courses, and as I listened to some of the students as they were giving feedback of this particular issue, I was not surprised, but caught off guard when one of the students had said, and this was one of the topics in the course, one of the students said that they were having to pull back product because counterfeit parts were found, and it was started to affect the downstream of functionality of the unit, which they didn't see up front, but downstream, they noticed issues. And when they evaluated and dug deeper, they found out they had several counterfeit parts, and they were spending a large amount of money to pull these back and then to replace these parts. So it's amazing how the effect of counterfeit parts or the integrity of the parts are now coming into play as well. It just shocks me.
Absolutely. I mean, I think you've got to look at it from a couple of angles, right? I mean, one is you've sort of got the authenticity of the part itself and whether you're using a trusted data set. I mean, today, it's almost antiquated to sort of think that all you do is put up a data sheet and that describes a component, and you don't really know if all that is authentic or not. It certainly, as you were pointing out, it really extends beyond that when you start looking at the relationship into the supply chain, right? And so not only do I get a component from a component manufacturer, that then goes to a distributor, from the distributor, it goes to an EMS. And at every point along that supply chain, at some point, we want to be able to get to the point where you can ascertain trust and traceability. And as you pointed out, sometimes, you get components which are counterfeit. Other times it's a little bit more, let's say, surreptitious than that, where the reel is a reel of genuine components, but a couple of them have been flipped out and counterfeits put in. And so eventually we want to be able to get to the point where we can understand where all the threats are in the supply chain and what the risk of that is. And so just as an example, not quite in the electronics domain, but recently one of the American fighters was grounded because they found an alloy in it that they couldn't be certain what the composition was, what the country of origin is. And so things like we don't only want to be able to make sure that the component is trustworthy, but that entire supply chain is trustworthy. And we have things like country of origin information that's then accessible at the product level.
That's really interesting. I mean, that really hits home when you think about it, when you design. And are you really designing? Do you know what you're designing? I mean, knowing the process is one thing and knowing your teams, but the actual parts that you're using, it's really interesting when you dig in deeper regarding the integrity of the part and the reliability, as well as, what we talked about here in this particular case with the signatures are, what is it? Is it validated from the manufacturer? What does it mean in the context of a company when they're evaluating what happens when boards are assembled? What is your take on that?
I mean, that's a great question, right? I mean, I think you've sort of got this at one level, what does it mean for an individual sort of PCB designer supplier, right? I mean, I want to make sure that my components are trustworthy. I want to make sure that I've got visibility into things like country of origin information that really builds up on this historic material declaration, right? I mean, how can I get all that information sort of shift left it again so that I've got a very high degree of confidence that I can build a reliable product? I mean, that's what I really want to come out of that. And then I want to be able to sort of extend that idea of a digital part model that's trusted, that I know the authenticity of it, and be able to look at that and extend it into my product. My product, in this case, being the PCB, that I can then say this PCB is trusted, right? Because I've kind of got this hierarchical ledger effect going, that the consumer of that PCB can then go off and do the same thing and say, hey, I can now tell that my product is trusted. Because that's what you want at the end of the day, is that the end product is trusted.
You're absolutely right. And I couldn't agree with you more on that. Tell me, is there value in knowing where an individual component are used in the portfolio of a product? Basically, like where used? I mean, would you agree that there's value, or can you extrapolate on that?
Sort of immense value. And I think you can sort of see that from two ends, Steph, right? I mean, one is if you do identify a counterfeit component, and now you've kind of got visibility into the supply chain to understand, where that threat may have arisen, and you've now identified this component, you really want to target the impact, right? And so we want to target What do I need, for example, to manage in a recall situation, which are hugely expensive? I mean, if I can really target this, what I recall down to a specific module or sub-module, that's absolutely tremendous value.
That's really encouraging, Matt. Here's my last question. So when companies are buying or optimizing using our solution, how will they verify component certification that a part is not counterfeit?
Yeah, we touched on this a little bit. I think, you've got one idea of this digital twin, this component that we can build. And then because it's digital, you can sign it. You've got an authenticator that signs it. So you've kind of got this idea of root of trust, a bit like I said in domain names today. And so, at that point, a company looking at our solution can say, hey, is that certificate valid? And if it's a valid certificate, then, I've got some level of assurance that that provider, that supplier of components, has completed all the relevant steps that sort of guarantee integrity of both their internal process and what they've put into the supply chain. So, I think you kind of get this idea building up over time of greater and greater visibility, not just into the component authenticity, but also into the logistics of the supply chain that go behind that as this ledger is sort of built up over time.
Wow. Thanks, Matt. I mean, that's very insightful information. This podcast culminates our series on the road to supply chain resilience. Do you have any final thoughts you want to share with the audience here?
Yeah, thanks, Steph. I mean, I think this is great, right? I mean, this has been pretty brief and we could spend a lot of time talking on a lot of these topics. I think what's clear is Siemens EDA is investing a lot. What we're doing in this component digital thread is really trying to create the idea of a very, very accurate digital thread from the component manufacturer right through to the OEM where that's used and the authenticity of that component, and then all the way down through the entire component ecosystem so that you can track that right down into manufacturing, into product. We're really right at the start of this transformation. The process is very historic today. There are hundreds of millions of data sheets that are just flying around. And so this is going to be a huge transformation for the electronics industry. And when we get there, and as we see the steps come in place, we're really going to see this fuel a new level of productivity and security for the industry.
This is why I love PCB design and have a passion for printed circuit engineering. It's a truly exciting time to be a part of this industry. And to all our listeners, make sure you tune in to the Printed Circuit podcast starting in January, where we kick off our new series on PCB design best practices.